Hello everyone, you're welcome to another exciting episode of the Green Living Chat Podcast's research segment.
Yeah, Daniel, it's always exciting to come your way again on a new episode with a new conversation. So what's up today? Who is on the show and what are we talking about?
In this episode, we discuss the deterioration of water reservoirs with Dr. Eyram Norgbey. We are calling this Blackwater.
Dr. Eyram Norgbey is currently an associate professor at the NUIST Reading Academy and a visiting researcher at the Federal Highway Research Institute in Germany. He has won several international awards, including the prestigious Green Talent Award from the German Federal Ministry of Education and Research. So on today's podcast, he joined us to discuss his exciting PhD research in the southern regions of China to find solutions to their water reservoirs.
Here, we explore some of the ways the quality of water in reservoirs degrades by looking at interconnected human and natural factors.
Today's episode was really exciting and we really can't wait to share this exciting conversation with you. It was also our first time having a face-to-face interview. How exciting!
We hope that you enjoy this episode as we have certainly enjoyed our interview with Dr. Norgbey. Let's dive into the conversation. Here we go.
You are listening to the Green Living Chat Podcast, a podcast where we discuss emerging environmental issues around the world, as well as related ongoing research to find sustainable solutions. This is the Research Story segment. I am your host, David Ewisi-Mensah, with your co-host,
Daniel Fifi Teria Hagen. We use this platform to support environmental-related initiatives, research, and projects through interdisciplinary conversations that promote holistic critical thinking.
This podcast is brought to you by EcoWamet Solutions in Ghana with a mission to going back to green. So join us on this train this and every Sunday. Here we go. Hello, Dr. Eyram. Thank you so much for joining us today on the Green Living Chat podcast. This is fun because today is the first time the Green Living Chat we're having an in-person recording in Daniel's studio. So it's really exciting. Welcome, Dr. Eyram.
Thank you so much, David. It's an honor to be here with you guys. I keep on listening to the podcast. I feel privileged to be here and doing this program with you guys.
Well, guys, I have to let you know that I know Eyram. We were in the same school and we're actually in the same research team under the same supervisor. And it's been really interesting. He's a really smart guy. And I'm really super excited to be talking about his research today because, I've seen him doing this research and several others. He has a lot to tell us today. So super excited. I do know you on a personal level, but of course, our listeners need to know a little bit about you, how you grew up. Tell us a little bit about your childhood in Ghana for sure, and how was the journey for you growing up and school and everything?
Okay, thank you for the opportunity. As David said, my name is Dr. Eyram Norgbey. I'm currently working in NUIST Reading Academy as an associate professor in the environmental engineering department. I spent 7 years in China. Doing my master's here for 3 years. And
oh boy.
So it's,
yeah. I'm surprised Daniel is smiling over this.
Yeah. But before coming to China, I grew up in Ghana, where I did my bachelor's degree in Kwame Nkrumah University of Science and Technology. I read civil engineering and yeah.
That's pretty much it, I guess. But what I always want to understand from my guests is we have a lot of young people listening to this podcast. And I find it very interesting if people just wake up and tell us that, yeah, they did this in for their bachelor's, they did that for their master's. And some people are really struggling at high school right now, thinking of how they can even get to the university, which course should they learn, what should they do with their life. What would you tell them as someone who has just finished your PhD? And really, by the way, congratulations on your graduation. What advice would you like to tell a young person who is listening to this podcast? What are some of the things that you should consider whilst maybe choosing your courses? And how do you even decide, do I want to go into academia or do I want to even go to the industry?
Yeah, thank you very much, David. That's a very good question. So, for me personally, my environment played a big role in deciding what I wanted to do in my career path. Okay, so for example, I worked with my mom. My mom had 20 years of experience in working in the water sector in Ghana, as water, sanitation, and hygiene. She worked with World Vision, she worked with Water Aid, and she also worked with Water Health. So, and even currently, she has her own NGO, which is GLODEP, which also focuses on helping women and helping the sanitation and water issues in Ghana. When I was growing up as a child, I had this experience with my mom, and I get to see all the water issues, all the sanitation issues, and all the challenges, especially in poor urban communities. So these were some of the factors in my environment that influenced my career path. And one thing that my mom always said was that whatever you are doing, she always has this acronym called FAT, which is FAT. F means you are faithful to whatever you are doing. A means you should always make yourself available to whatever you are doing. Because if you are not available to whatever you are doing, really the input is going to be bad. And then you should also make time for whatever you are doing. So that's a T. So it's something that has guided me throughout my path, whatever I'm doing, moving from high school to the university, moving from the university to postgraduate studies, and even doing my PhD and currently working as an associate professor. So whatever I do, I just apply the FAT principle, and it has been very, very beneficial. And I have so many testimonies based on applying this principle. There's this Green Talent Award, which is awarded by the German Federal Ministry of Education, where they pick up talents working on sustainability, young researchers trying to solve environmental issues. So I just saw this advice. I said, I looked at the requirements and then I fit perfectly into the requirement. And I said, that, okay, let me just give it a try. And then the application requires a lot of input. So I applied the FAT principle. I was faithful to the application. I made myself available. And then with time, my application was ready. And then I submitted it. And I was chosen among 600 applicants across the world. And I had the opportunity to even do some research in Germany. My advice to the young researchers, whatever you want to do, right, just have a good attitude, be dedicated, be faithful to it, make yourself available and dedicate time to whatever you are doing. And with the help of God, everything.
I see Daniel smiling a lot. I don't know. Do you want to say something?
I mean, it's remarkable. I really appreciate how you are encouraging anyone who is listening to this, and I think we need more of that, especially for the upcoming scientists out there, no matter where you are. And I mean, we have come from some places, and we know that some of these things, they only felt like dreams for us, and today we get to explore them in very fun ways, and we want others to also experience this. So I really appreciate your encouragement, and definitely we're going to get fat. I guess this is something I'm going to tell myself. I'm getting fat.
Yeah, really. Okay, so let's dig deeper into our conversation for today. How did you arrive then in sustainability related stuff? You've already given us a preamble that, I mean, some of these things were just around you in your surrounding. I've had several conversations where people are always telling me how they started getting these traits from their parents and other things. But for you personally, when it comes to research, how then did you start developing interest in, let's say, specific topics? Because I know you've done things on lignin, you've done things on wastewater, and even choosing your professor in our university, you chose someone who is working or specializing in a water-related research. So how then did you arrive in these specific things? Yeah.
And if I can just add something
Sure.
that, because you mentioned that you started with civil engineering,
Yeah.
and I think that it's going to be something that someone who is not very clear about is thinking, how do you get from civil engineering to what you are doing now? And did you have to make a complete switch, or is there actually is it a continuum that anyone can comfortably transition into these kinds of areas? So if you could include that as well, I think that would be very helpful.
Normally in Ghana, when you finish GSS, most of the time your parents want you to do science. So it's a very common thing in Ghana. So right after I finished high school, I entered a university and I read civil engineering. But one thing about civil engineering is it's one of the broadest engineering programs in Ghana. And civil engineering has four major aspects. The first one is structural engineering, and we have water engineering, we have waste engineering, and we have highway engineering. So in the first 3 years of your life as a civil engineer, they'll teach you everything, all these four aspects. But when you get to the final year, you make the decision to decide on which path that you would want to go into. Yeah. So in the final year, I moved in the water aspect of civil engineering. But thanks to the guidance of my parents, because my mom was an educationist, so she was always available to advise me on my career path.
Yeah. This is very good. Actually, I probably discussed it with David as well, that before I came to China, one of the things I was doing was going to high schools with a group of colleagues to talk to high school students about some of these areas they could explore. Because when we hear civil engineering, we're only thinking about buildings and bridges, and we don't know about the hydrological aspects and all these. And personally, I actually came here in China to do structural engineering. That was what I wanted to do because of my love for geometry. But then I just fell in love with what I'm doing now. I think it's really good, and I like the fact that at least someone listening to you would know that there are more engineers, not just about putting up a building, but actually I could be doing so much more. And I have the chance to learn all these things, and then at the end of the day, see where I'm falling in love with and pursue that. So thank you for that. Yeah.
Growing up in Ghana, most of the time when you see the water bodies in Ghana, like rivers, reservoirs, you would see that sometimes there are some black substances developing in the water body.
Yeah.
And a typical example was growing up in Accra, there's one that we call the Odo River. And anytime we passed by it, one, it had this awful smell. And then the second one was you would see black substances on the surface. So it was a question that I kept on asking myself. So like I even asked my parents that like, what is the cause of this black substance? And well, no one was able to like clearly explain what is the mechanism or the process behind the formation of these black substances. So this was I had this curiosity about Blackwater, and even when I entered my bachelor's degree, I even worked with a professor who was working on water. So my bachelor's degree thesis topic was actually water supply to poor communities in Ghana. So my love for water started as a very, very young.
Just in order for our listeners not to get too confused, you may have touched on it, but I think if you could also maybe from the technical to an easier to understand version, just define what Blackwater is before we proceed, because you'll be using that term a lot, and we don't want anyone to get lost. Yeah.
Okay. So to just define it in a very simple way, the appearance of malodorous substances, which is black in nature, on water bodies. So when you just see substances that has the malodor smell and then it's black in nature, I'll be terming that as black water throughout this presentation. So it's not anything complicated, it's very simple. So just black substances in a freshwater system, which is which deteriorates the freshwater body.
But you wrote a very complicated paper.
Yeah, but during this presentation, I'll try and make things very, very simple. Yeah, so that the layman, everyone can understand what I'm doing. Yeah.
Okay, then so let's dive a little bit into your PhD research, right? So today we really wanted to have conversation about what you just did for your recent research, which is on black water in reservoirs within the southern part of China. So what led to this research actually?
So thank you very much, David. When I started my PhD, I looked for professors that were working in the water sector. For my school, you could go to their website and see the research topics that the professors are working on. So I came into contact with a professor, Professor Lee, and I realized that he was also working on Blackwater. But this Blackwater was a little bit different from what I came across as a child growing up in Ghana. This Blackwater occurs in southern China and it's very unique and very special. I say this because this phenomenon in summer, you have a water system that is clean. You have no visibility of black water. But in winter, everything changes from clean to black. Then the cycle repeats again. In summer, it's clean, and in winter, it's black again. So the people in the local area were even worried about going on, and so they even decided not to use the water again because it's really strange. One time it's clean, no, there's no problem with it, and another time it's completely black. So it was a very interesting topic. So I decided to explore and see the main cause of this problem.
This looks very interesting to me. As you were saying, I think this is a lake. Are we talking about a reservoir as in a lake, right? That's what we are talking about. Perfect. So mostly what is happening in the industry, we have several reservoirs in all around the world. What do people build reservoirs for? And what are some of the common challenges that we have in these systems?
So generally, reservoirs are used for controlling flood, generation of electricity, some even practice fishing, irrigation, farming with reservoirs. So generally, reservoirs have a lot of uses, but sometimes human activities, anthropogenic activities around the reservoirs. For example, if you are farming close to the reservoir, the application of fertilizers and other human activities. So when it rains, the rain washes the organic matter and then the excess fertilizer applied in the soil into the reservoir or lakes. And sometimes this is recognized through eutrophication, which is algal bloom. And in other cases too, we have the black water phenomenon. Normally, this occurs in a water system that has a very low gradient. Okay, so for this to happen, the water needs to be still. Okay, it should be moving at a fast pace. The water should be idle at a particular place. So normally, this phenomenon is common in rivers having a very low gradient, meaning the water is not moving at a fast pace, or you have a reservoir where the water is blocked and is stored at a particular place, so there's less movement of that water, and also in lakes where the water is still.
We've been having conversations also about like the human footprint on the environment. And the thing is, we need to make these waters static so that we can also, as you said, farm, have enough water for irrigation, have, prevent floods in the cities that we have created downstream. And also, I don't know, to do so many things. But also there is another side of it, which really impacts the environment as well. It's very interesting, but sometimes it makes me think about, so do we actually have environmental impact assessments about these things? Or sometimes we just have to say that the benefits overweighs the disadvantages. So, but well, I mean, this is a conversation for another day.
I'm getting more and more questions coming up in my head. Okay. I guess we can start with the basic ones of what are the causal factors. You've already started touching on some of them, and I really want us to try some sort of a 360 discussion on this. So, if you share with us, what are some of the insights that you got from your research on what is happening?
So, David said human activities play a significant role in the black water, even the deterioration of water bodies. But in my PhD research, right, we looked at it in two aspects: factors caused by human activities, and then natural factors, the ones not caused by human activities. So for my study area, you realize that even though human activities play a big role in black water formation, in this study area, the water that we investigated had no human activities around it. So this black water phenomenon that was occurring was something that was occurring naturally and wasn't influenced by human activities. You have a water system where the water is pumped to a treatment site where they clean the water, and then it's pumped to the homes and they use the water. The water treatment facility realize that in winter the water becomes black and in summer it is clean. And they also realize that there's no human activity around the reservoir. So they are confused. They don't know whether they should continue treating the water and distributing the water to the homes, or they should stop because it's a problem that they are facing. So once we are able to do this in this case study area, we could realize that other areas across the world where there are water bodies and there are water systems without human activities also face similar conditions. So this is something that once we could understand the mechanism, we can apply it in different area of studies and then find sustainable and long-lasting solutions to this problem. One of the factors that we realized was that season played a big role in the Blackwater formation, because we realized that in summer it was clean and then in winter it was black. We had to investigate why the intense heat and then the coldness played a big role in the Blackwater formation. And then another factor that we also had to take into account was the nature of the soil around the reservoir. So yeah, we also hypothesized that that played a big role in the Blackwater formation, and also some of the organic material, the trees around the reservoirs. We had to do detailed analysis to see whether these organic materials also play a role in the water body, because most of the time when you have a lake or a reservoir, most of the time they are surrounded by trees or organic materials, and these materials come into contact with the water during rainfall, strong winds, and a lot of natural factors. So these were the three main.
I don't know, but it looks like there are a lot of variables
Yes.
that you're looking at over
Yes.
there. That is already giving me some headache. And sort of like, okay, all these variables have their unique characteristics. What were the major contributors to this? Because we have all these things, and I'm sure you sorted out your contributing factors.
Yeah. So the main factors that were responsible for the Blackwater formation were seasons, and what happens during the seasons is a phenomenon that we call thermal stratification that happens in the water system. Okay, so thermal stratification is a process whereby heat from the sun affects the temperature gradient in the water system. So for thermal stratification, we realized that in summer, when the heat was intense, we had strong stratification in the reservoir. Okay, so what this means is that the surface of the water would have an extremely high temperature due to the heat from the sun. But as you go down beneath the water, we have a low temperature. So it means the temperature difference between the surface of the water and the bottom of the water in the reservoir was very, very significant. So if it is significant, right, there will be no mixing of the reservoir because of the significant difference in temperature. Then when we move on to winter, right, we realize that there's a cooling effect due to the winter season. So winter, you realize that the temperature from the surface to the bottom is a bit uniform. Okay, there's no significant difference in temperature between the surface and then the bottom water. So since the temperature is uniformly distributed in winter, we would have significant mixing of the reservoir. So one thing that we had to pay attention was that in summer, the reservoir wouldn't mix, but in winter, due to the uniform temperature, the reservoir was going to mix naturally on its own. Okay, so that was one of the factors that played in the Blackwater formation. And here the key word is mixing. And then in summer, because we have significant difference in temperature differences in the surface temperature and then the bottom temperature, and then there's no mixing of the reservoir in summer, you realize that the surface of the water has direct contact with the atmosphere. So the surface of the water has high dissolved oxygen content, but however, because there's no mixing of the reservoir in summer, the bottom of the reservoir wouldn't have enough oxygen due to the difference in temperature. So the low oxygen content at the bottom of the reservoir also begins to develop and causes other factors to come in. So this is where I'm going to explain hypoxia and how all these processes takes place and causes blackwater. So in summer, when the bottom of the reservoir doesn't have enough oxygen, a process called hypoxia or anoxia takes place, where the oxygen content is less than 2 milligrams per liter. So when this takes place, right, there's not enough oxygen at the bottom of the reservoir. So organisms like fish, phytoplankton, all living organisms that depend on oxygen for their survival, they don't have enough oxygen at the bottom. So they begin to die. And when they die, when decomposition of these materials take place, even decomposition also consumes more oxygen in the process. So this causes the bottom of the reservoir to be anoxic. So first it's hypoxia, but when the oxygen content is extremely low, then anoxia takes place. And when it becomes anoxic, right, we have the elements in the sediment also beginning to act. So if you have an anoxic environment, we have iron-reducing bacteria having its effects on the bottom of the reservoir. We have also sulfate-reducing organisms having their effects on the sediment at the bottom of the reservoir. So I'll start with iron-reducing bacteria. So naturally, when there is oxygen, right, we have iron will exist as iron 3 oxide. But when anoxia sets in, right, the iron 3 changes to iron 2 and it becomes mobile, readily available, high mobility, high remobilization, and then the bioavailability of the iron 2 also becomes very, very high. So that's the iron reducing bacteria. They reduce iron 3 to iron 2 at the bottom of the reservoir. Then we also have the sulfate reducing bacteria, that converts sulfates to sulfide. So now at the bottom of the reservoir, we have low oxygen and iron reducing material is taking place, sulfate reducing material is taking place. So you have high concentration of iron 2 and they have high concentration of sulfide, which is S2 minus. So these elements also combine and then they form iron sulfide, which is naturally black in color. So in summer, this is what is happening at the bottom of the reservoir. You have low oxygen and then iron 2 and sulfide combined, giving you the black materials at the bottom of the reservoir.
Hi there, just a quick one. So if you're enjoying this conversation, why don't you just share this episode with a friend of a friend? And let's get more people to listen to this episode. The urgency of climate change and humans reducing our impact and footprint on the environment is a necessity. And these are the conversations we need to promote. You can also help us by giving us a star rating or sharing your comments on whichever platform you are listening to this episode. Visit our website and our social media platforms in the show notes and get interactive with us, or send us an email at glcpodcast@ecowametsolutions.com. So thank you in advance. Let's get back into this conversation.
But because there's a strong difference in temperature between the surface water and the bottom water, there is no mixing. So the locals look at the water and the water is clean. They just look at it on the surface, but they don't know what is happening at the bottom of the water. That's why they think the water is clean in summer. Then we move to winter, where there's a drop in temperature. So when there's a drop in temperature, there's a uniform surface. Water has a low temperature. The bottom also has a low temperature. So when there's a uniform temperature in winter, there's going to be mixing of the reservoir. And iron sulfide is stable. Once iron sulfide is formed, when oxygen comes into contact with it, it doesn't change. It's stable as it is. So this forms at the bottom of the reservoir, and then in winter, when the water mixes, now the iron sulfide surfaces on the surface. That's one of the factors how Blackwater occurs. Then there is another factor. So earlier I said that we had to investigate the soil, we had to investigate the seasons, and also we had to investigate the organic material, the trees around the reservoir to see if they also play a significant role in the Blackwater. We investigated the trees and realized that, okay, this problem, it was occurring in a lot of reservoirs in southern China. And then one factor that kept on appearing in all the reservoirs was this particular plant called the eucalyptus plant. And the eucalyptus plant is normally grown in southern China because it grows very fast and the wood industry needs a lot of wood. So it's important to grow a tree that that grows fast within a short span, and then you can harvest it quickly and then use it in the wood industry for your chairs and furniture and all that. So in southern China, it's very popular because of its fast growth rate. And we did a background research in other countries and we realized that okay, eucalyptus is also popular in Australia, and we realized that Australia also had this Blackwater issue. So we also hypothesized that then this eucalyptus tree is playing a big role in the Blackwater phenomenon. So what we did was that we realized that whenever it rains, right, the rain washes the leaves of this tree into the reservoir. And then we realized that one, there's going to be high organic matter in the reservoir. And once the organic matter from the tree decomposes, decomposition requires the use of oxygen. So once the organic matter finds its way into the water and they decompose, they consume all the oxygen in the water. And once the water becomes hypoxic and anoxic, then the iron and sulfide process takes place. And then another factor that we saw with this eucalyptus tree was the presence of tannins in the eucalyptus tree. Okay, and then tannins.
Sorry, what are tannins?
Okay. All right. So when we talk of tannins, right, what the simplest explanation is Chinese tea. So when you have the Chinese tea, you put the leaves in water, you realize that the color changes to yellow. Yeah. So that tannins is what is responsible for the color to change to that yellow color. Yeah. So normally trees that have high tannins, when you investigate the water bodies around them, when the tannins concentration is very high, you realize that you have like a yellow, the water looks a bit yellowish, not completely colorless, as compared to a water system without the tannins. The eucalyptus tree has high concentrations of tannins. Okay, so we felt and believed that the tannins was also responsible for the Blackwater. So we did several simulation experiments in the laboratory to mix the tannins with different chemicals to see which one would give us a black substance. Then we can confirm that this tannins reacted with this to give us the black substance. So from our results, we realized that the tannins reacted with iron. And mind you, most of the soil in southern China have high iron concentration. So once tannins comes into contact with iron, whatever the form, it could be iron 2, it could be iron 3, it will definitely give you the black substance. Basically, those were our three main findings. We like 5 major publications in this area, and each of the publications explains each aspect into detail how they contribute to Blackwater. You could visit my ResearchGate profile and then you see the publications and you get in-depth information.
I'm definitely going to visit the thermal certification because it's producing a lot of things in my head, and I'm not going to get ahead of myself. David is interested in similar cases that are also all around the world, but I'm more interested in different cases that are all around the world. And the reason is, for instance, the leading contributing factor. I'm looking at I've written on my note the hierarchical causes. I guess that the assumption here is that the reservoirs that we are talking about are human-made reservoirs.
Yeah.
Okay. So,
There's no way we can do this thing without human effect.
Yeah.
Yes.
I mean, this is really important because in the Intergovernmental Panel Climate Change report, it's very important to always note the anthropogenic effect, the impact of humans. But the reason why I want to bank on the differences here is that I think for me, as a climate scientist, different climate conditions in different places would therefore result in the cycle of the Blackwater.
Yeah.
And I think this for me makes me understand at least that in cold places where we would have maybe longer winter or something like that, or colder places, we would have more mixing going on over there. And I'm thinking to myself, in a place like Ghana where at least we come from, I'm sure there's a lot of Blackwater situation going on. But then the climate there is generally warm,
Yeah.
warm there. So it looks to me like these these hierarchical courses would also change from place to place,
Yeah.
right?
I agree.
Yeah. Okay. So because you said you studied into the different courses, at least in the thermal certification, were you able to look at sort of under different, just probably hypothesizing that under different climate conditions, would we expect more black waters in some places and less black waters in some?
So in this research, we even compared a case study in Australia where we have the Murray River,
Okay.
which also experienced black water. Okay, and then when you look at this river, right, this river that doesn't experience thermal stratification. One thing I left out in my previous explanation is that the depth of the river plays a big role in thermal stratification formation. So even if we have a place where we have different seasons, if the reservoir or the water body is not deep enough, thermal stratification would not take place. Okay, so the depth plays a big role. It has to be deep before thermal stratification will take place. So looking at the case study in Australia, the Murray River, where the depth of the river wasn't deep enough, but black water occurred over there. So I believe that this case study in Australia can be applied to different regions. For example, Ghana, where we have the same season, the same weather throughout the year. If you have your water system, which is not deep enough, so we have no thermal stratification. However, the gradient of the river is very low, which means the river is not flowing at a high pace due to the low gradient of the river. And here we have a lot of organic materials finding its way into the water system. And once this organic material keeps on decomposing in the water system, it's going to consume a lot of oxygen in the decomposition process, because a lot of oxygen is needed in decomposition. And when this takes place, right, we'll have the hypoxia situation and anoxia taking place because decomposition is getting rid of the oxygen in the water. And once we don't have oxygen in the water, organisms will suffocate and die. And once they die, more decomposition is going to take place. And as more decomposition is taking place, they'll consume more oxygen, making the water extremely anoxic. And when it's anoxic, then that's when the sediments also take place. We have the iron reducing bacteria and the sulfide reducing bacteria doing their thing, and then iron and sulfide takes place. But it's very important that you know the nature of the soil, whether it has iron. Another element that can also help in the black substance is manganese. Okay, so manganese also, when there's low oxygen, right, we have Mn2 plus available, which can also react with the sulfide to also give a black substance. So it's very important that we study the nature of the sediments and the soil around the reservoir. So when we take away the seasons out of it, where there's no thermal stratification, where we have a region that has the same weather throughout, then, like David said, human activities that will cause organic materials into the water would cause the consumption of oxygen. Then the cycle repeats itself over and over again.
Wow.
What is really going through my mind when you actually mentioned the things about the tree was that, there is this conversation that is going on about planting of trees all around the world. People think that planting trees is going to save the world. Of course, that is it. But we have to also understand something about indigenous species. So we cannot just go around planting trees. So now it brings to mind, because earlier you've also made mention that most of the factors that you looked at did not have any direct contacts to human activities. But for sure, if you realize also these kind of trees are planted all around southern China because of the benefits it has for a certain industry. And they might not have been, maybe, I'm not sure about this, they might not have been the indigenous species around these water bodies. So it makes me think that, so is it okay? It's definitely okay, because we need trees around water bodies to keep them safe and not to also dry up, of course. But so how do we find the balance? I don't know. I'm just thinking, it's not really a question, but I'm just thinking that, so is it, how do we find the balance in planting trees around these water bodies? And I think my actual main question was that, looking at all these factors that you've mentioned, it doesn't seem to have any negative impact apart from, the reduction in the dissolved oxygen in the water. Does it really have an impact on human health if they drink it? I mean, was there any conversation with the people, or was there anything like that? Or in your thoughts, do you think that, looking at the parameters compared with maybe EPA standards or something like that, is that water okay, apart from its black looking nature, to be used as a drinking water also?
So that's a very good question. In southern China, the inhabitants don't drink directly from the reservoir. The water goes to a water treatment site where they treat the water to meet Chinese standard and then EPA standards before they distribute the water. But from research, right, when there's too much consumption of iron, sulfide, and manganese, they will definitely have some health implications on the individual. But here is the case where the water is normally treated before it goes to the public. But what I would say is that for the Blackwater phenomenon in southern China, for the tourism industry, right, they are very interested in sites, sceneries, and all that. So once the water turns black, right, it's a big problem for the tourism industry, and then lots of money would need to be pumped into it to get the aesthetic view, to make the water clean. And also another thing that we need to take into account is the food chain and then the ecosystem. So if you have this black water, right, like sunlight is very important for the microorganisms in the water system. Like the phytoplankton, they all need direct sunlight for their survival. And even the plants beneath the bottom of the reservoir, they also need a good amount of sunlight for their growth. But when you have this black water occurring in the water system, it prevents direct sunlight from coming into contact with these organisms, since it hinders the sun rays from coming to this organism. So this plays a big role in the food chain, affecting the phytoplankton. You know that the fish and other organisms depend on each other in the ecosystem. Yeah.
Oh, this is really important, because before I started my PhD, for about I think half a year, I got so hooked up on phytoplankton research,
Okay.
because they are so important in when we talk about climate change. And so I was into studying the effect of phytoplankton on the climate between the Amazon and the Sahara Desert, because the Sahara Desert would take a lot of materials, and even all the way to the Amazon. And,
Wow.
and phytoplankton was very helpful in regulating these things. So Blackwater becoming a hindrance to the activities of phytoplankton, I think is definitely important to climate scientists. I didn't know that.
As Daniel mentioned, it's so important because this is actually the beginning of life. This is what's actually drive the sustenance of the ecosystem. So it's really, really important. I'm still brainstorming on how this can be solved, because if we look at the kind of black water we see in different regions, it might be different from what we are looking at in this region, because some might be due to maybe direct human activities, like maybe chemicals, agricultural stuff, runoffs, and those kind of things. But in this case, it looks like more of a natural, like an indirect human activity, but more of a natural phenomenon, right? I don't know if your research went into how to solve this, or how to, prevent this from happening.
So for this research, like you said, it's mainly about natural factors playing a role in the Blackwater phenomenon. And one of the factors that we talked about was thermal stratification. So we realized that if you have a reservoir that is deep, thermal stratification will occur. And when thermal stratification occurs, it's going to play a role in the Blackwater formation. So one thing that we can do is try and allow oxygen to be always available at the sediment water interface. Because once the sediment water interface is anoxic, then you have several chemical processes taking place producing black water. So one of the recommendations that we gave was that we could try and install machines that would constantly be mixing the water, sometimes called aeration machines. Once the water keeps on mixing, oxygen from the outside gets to the bottom of the water, or other machines that can pump oxygen directly to sediment water interface. And we could also look at the construction of buffer zones around the reservoir, because organic materials, and in this study, specifically eucalyptus trees, may find their ways into the water system. So if we construct a buffer zone around the reservoir that could trap these excess organic materials, then will prevent these organic materials from coming into contact with the reservoir, which I think would require huge capital for it to be done. But I think on the long term, it will be very, very helpful. And then we could also look at some latest research works which is done where some specific chemicals can be pumped into the sediment water interface. So here we have hydrogen peroxide as an example, where you put hydrogen peroxide at the sediment water interface, which can directly prevent the black water from forming. Yeah. And most importantly, the human activities is very important that we try to reduce human activities. Yeah.
I find that, I mean, from what you're saying, we would really benefit from interdisciplinary conversations.
Yes, definitely.
Means that there is a lot going on here that one group of people cannot really deal with. And so, is this something that you are doing already, or is this something that you're looking forward to doing? Because, I mean, one question for me, for instance, is that are you considering recycle rates from rainfall? Because the rain is coming in. As a climate scientist, forgive me. I mean, these can be at these can be at very minimal rates, but we have evaporation, which is taking water out, and then we have rainfall, which is bringing the water in. And this is something that I am also actively studying over China and the southern China. And southern China receives more recycled water than any other part of the country. So I'm just thinking that, do you think or do you speculate that this has any role on it, or does recycling help? If we are to allow nature to take its course, will this will this help? I don't think it's a very realistic question, because I think we have to wait a long period of time to see some of these things taking place. Nonetheless, they we can't. I think there's also something that we should be looking at. So I think a research would definitely benefit from interdisciplinary conversation. So yeah, to our listeners, Dr. Eyram is a brilliant scientist, and he welcomes you to.
Yeah, I think you've just reminded me of something that we are working on. So actually, this project started in the second year of my PhD, and we've been observing this for 2 years. And when we started the research, I realized that the water level kept on decreasing with as time goes on, which comes into the evaporation that you were talking about. And we also realized that when the water level kept on decreasing, the intensity of the black water kept on increasing. It was becoming very, very obvious. The black water. So I agree with you 100% about maybe another PhD person can explore, because looking at this, like the title that comes in my mind is Water Depth Influences the Mobility of Toxic Elements at the Sediment Water Interface, which is something that we can look at in the future. So I really
someone's PhD.
That's very interesting. Yeah, because I'm thinking earlier you mentioned that the depth of the water actually plays a very significant role. So if the water is evaporating, well, the levels of the water is going lower, which means that depth is actually decreasing. So which means that if we are still also seeing the effect of the black water, high, which means that other factors are now playing a more significant. Yeah, yeah. That's very interesting. And I was also thinking around the solutions that you also mentioned. A lot of people will argue, let's say, for, or I mean, there could be a lot of arguments around it because it's very, some of the solutions you mentioned are very energy intensive, and also all the things that are revolving around energy and all those things. So I think it brings in the need for that kind of conversation or collaboration with other people from the other side to see what could happen. Civil engineers could also look into where they could build their reservoirs, right? I know that they always want to make sure that they have like enough, let's say, land so that they can support the wall that they are building. But of course they also have to understand that, well, the plants that are around it and also where they put the wall could affect the depth of the reservoir behind the wall, so which could also contribute to this. In as much as we haven't really identified the direct impact to human health, we cannot close our eyes on the impacts that it has generally on the ecosystem, which will indirectly affect humans. So this is a very interesting research. I think we are actually getting to the end of this conversation, but it's it's interesting. So now, what are you doing now, and which areas are you open for collaborations? I mean, what kind of research are you seeking to do? Are you going to do a postdoc now, or what's happening now? Tell us more so that people who are interested could collaborate with you.
Currently, I'm going back to a research that I did in my master's, and that gave me the Green Talent Award, which is also on sustainability. So basically, it's lignin. Lignin is an environmental friendly material. Most of the time, people ask me, what is lignin? Lignin is normally obtained from the paper industry. So anytime paper is made from wood, there's this waste material which is a natural material called lignin, and most of the time it's produced in large quantities, and then most of the time, because there's not significant use for it, it's normally burnt and to serve as a source of fuel in other industrial activities. And what I was working on was trying to combine lignin with bitumen for sustainable roads. And we all know that bitumen is obtained from the oil industry, and then there's so much pressure on oil products. So the goal of this research was to try and find an alternative to an oil material, which is bitumen. The early studies show that it's possible to use 30% of lignin as a replacement to bitumen for road construction. I work with leading scientists in Germany, Dr. Volker Hesch, and with his experts and advice, we're able to get good results. So now this is what I'm looking at, and I'm going to build upon that research in the near future.
So, I mean, if you've been following this conversation and you're interested in Dr. Eyram's work, just go down into the show notes. All the details and links to contact Dr. Eyram is being in the show notes. So get in touch with him via LinkedIn, via his email, and also on ResearchGaze to see some of his papers. And he has told us a lot of things about sustainability and all that. But generally, I mean, combining your research and your the things that you've learned from your mom, your dad, and growing up in Ghana and all those things. You have been working in the water industry, let's say, for some time now in sustainability. If you have the chance to change just one thing about humans' behavior towards the environment,
I would wish human beings could love the environment very much, because I believe that when you look at the solar system, it's so big, but the Earth is tiny, just a particular dot. And I believe that God just chose that particular dot to give life to that black one. That's Earth, that small dot in the solar system. So it's only one Earth, and we need to change our attitude towards it. We should love it, and then we should care for it like our own baby.
Yeah, so Dr. Eyram, really thank you so much for joining us today on the Green Living Chat. It's been a very interesting conversation. I just really wish that we could go deeper into this, but I know that for sure we're going to have a time again to even talk about your lignin project, and maybe by then we could have some more collaborations on that area, and we could even have maybe you and your new partners to come on board to tell us what you guys are doing. But really, I think that the take home message is we are having so many conversations and from different people from different regions, and it boils down to the same thing, that human impact on the environment is just becoming overwhelming, because whatever we do, there is nothing on earth that we do that doesn't leave a footprint. And so even look at the solutions, just as Daniel was talking about, it still has an impact. Growing trees, it still has like an impact. So when are humans really going to sit down, come together, and really try to find, probably go back to using less, consuming less, doing things like, I don't know, like the things of old, like doing things in a simpler way, so that we can love nature and nature can also love us back. It's a very complicated conversation which is still going on, and I don't want to go in now, but really, thank you so much for adding your voice on this, and your research is just super amazing. I know that this is some people are gonna pick up a lot of things out of this. And with that said, really, I appreciate your time today. Daniel, I don't know if you have some. Normally, researchers love to say shout out and say thank you to some people. So do you have any last words or? Yes.
Okay, so shout out to Dr. Huang Jiyu. He was my first professor in China. He had big plans, huge vision, and then he encouraged me so much. I'm at this position just because of the belief that he had in me, and a big shout out to him, to Dr. Borkahesh in Germany for helping us develop the research on lignin for sustainable roads. And then a shout out to my wife too.
Yeah, I was about to say that. I was
Okay.
about to say that.
Yeah, shout out to my wife for the support during my studies, for the moral support, the physical support, and the emotional support. A big shout out to you. God bless you.
Yeah, she's also a co-author on the paper, so she definitely deserves.
Yes, on all my papers.
Right. Thank you so much, Dr. Eyram.
Thank you, Daniel.
And, it's been fun. My first time co-hosting. So yeah, I look forward to learning more and really engaging in very interesting conversations. I hope that Dr. Eyram was able to give you guys some thesis topics and some paper topics as well. All right. Thank you very much for joining us.
See you in the next episode.
Thank you so much for listening to this episode of the Green Living Chats podcast. This has been the Research Stories segment. We believe that critical thinking is for everyone, and no one story is an island. We hope that you find where your story meets others here.
We look forward to hearing your thoughts and comments as we get interactive on our social media platforms at Echo Ahmed Solutions on Instagram, Facebook, YouTube, and LinkedIn. If you would like to be part of these conversations, contact us via email at glcpodcast@echoahmedsolutions.com or see our contact details in the show notes. See you on the next episode, and remember, live green.